Hello, I'm Bill Jacoby, Senior Solutions Architect. Welcome to our webinar today, Microsoft Workloads on Amazon Web Services. In today's webinar, we're going to cover a number of topics that relate to running the Microsoft servers on AWS. And you can see my agenda here. Why would you want to do that? How has Amazon itself as a large corporation migrated to Amazon? We'll dive a little deeper into a Windows architecture and a Microsoft Server architecture on Amazon, and we'll talk about the various technology that makes this all happen. So the first question that comes up is, why would you want to run Microsoft servers on AWS? And the reasons that apply to other cloud workloads as well apply to the Microsoft servers. So the first reason is agility, and agility is all about being able to add additional web front ends to SharePoint, for example, or automatically resize your SQL Server to support a greater database transactional load, or being able to do dev and test all in a matter of minutes on a cloud platform. From a cost perspective, you can actually save money running the Microsoft servers on Amazon versus on premises. And the reason for this is, number one, you only pay for what you use, and you turn on and turn off resources elastically according to demand or your needs. In addition, there's a good TCO story for running the Microsoft servers on Amazon, and the TCO story is based on the fact that we can take existing licenses that you have, allow you to transfer them to Amazon, and then tune all the resources that you have available to run the Microsoft environment in a cost-optimized way. Elasticity, resources are provisioned according to your actual demand. You have horizontal and vertical scalability. Breadth of functionality. This is actually one of my favorite reasons for running the Microsoft servers on AWS. You can take advantage of different size instances. That's our term for virtual machines. You can play around with, do I want to use SSD storage? Do I want to use provisioned IOPS, which is an enterprise level of SSD storage? Do I want to use spinning disk in order to save money? You have lots of options. We also have different databases. You can run the Microsoft servers using SQL Server running natively on EC2, or you can use, for example, our managed instance of SQL Server called RDS, Relational Database Service, which provides a managed version of Database as a Service with SQL Server. You can see some of the other services that we provide on AWS. The latest one that we announced in 2016 and will soon be going to general availability is the one that's called VMware Cloud on AWS. And when that service is available soon, you'll be able to take a Microsoft server's deployment on premises, vMotion it to AWS. AWS will be yet another site within your vSphere set of data centers, and the exact same servers that you're running on premises will be running in the AWS cloud on this VMware layer that sits in the Amazon global infrastructure. And so with no changes and just a vMotion, you can pick up and move entire farms, whether it's Exchange or SharePoint or Skype for Business or really any workload that would run on VMware on premises. The last reason I'll mention here is you can go global very quickly and easily. So you can take one of these farms and you can deploy them across the 16 regions, across the world. We're up to 44 availability zones. We've recently announced 6 new regions spanning Europe, the Middle East, China. We've added a second GovCloud region. So lots of great cloud benefits for running the Microsoft servers. And if we drill down a little bit more, there's a number of reasons that are very specific to the Microsoft servers for running them on AWS. Number one is compatibility with add-ons and ISV applications. And this is a direct result of the fact that we're running the on-premises bits on AWS. So because we're running on-premises bits, anything that runs on-premises and add-ons and customizations, for example, if you've created your own custom ASP.NET master pages or made other changes that call into the SharePoint or Exchange or Skype for Business object models, all of those enterprise customizations add-ons, ISV applications that you've purchased. If they run on premises, then they'll also run on our infrastructure as a service platform. Now, because we're running the on-premises bits, we also inherit all of the AWS controls, and we can provide a compliance solution for the Microsoft servers that inherit the controls that we've made available under various compliance regimens, including NIST, PCI, and HIPAA. And we have a number of accelerators that give you a sandbox so that if you run the Microsoft servers or other workloads in these sandboxes, then you automatically inherit the NIST 800-53 controls that gives you compliance for these different areas. License management. A lot of customers ask the question, am I licensed to run on the AWS cloud? And the answer is yes, you absolutely are. And you can either bring your own licenses or use licenses from AWS for Windows Server and SQL Server. If you're running your own licenses that you've used BYOL to import into AWS, then our service, AWS Config, can monitor the fact that your licenses are assigned to dedicated hosts and that those licenses aren't being moved off of those dedicated hosts in anything less than 90 days, which is a requirement of most of the Microsoft server licensing. So our software, AWS Config, will allow you to report and show that you're in license compliance with the Microsoft servers. We enable auditability. So for a lot of federal and public sector customers, it's very important to be able to document through logging that what you've set up on your infrastructure is exactly and only what you're running on your infrastructure. And so we have a number of tools, which I'll cover a little further in the deck, that provide auditability of what happens on AWS, of the network layer, and of all changes that are made to the infrastructure. Now, one of my favorite features for the Microsoft servers is that you can take advantage of DevOps capabilities, in particular AWS CloudFormation. And these DevOps capabilities become packages for the Microsoft servers that allow you to basically run a template, a CloudFormation template. And that template is basically a cast die, allowing you to stamp out not only individual servers, but entire server farms, where you can say, if I've configured a server farm for SharePoint or Exchange, I can just stamp one out in US East, in US West, in GovCloud, and CloudFormation allows you to have infrastructure as code that's repeatable and allows you to stand up the Microsoft environment essentially by running a template. Now, what's nice about CloudFormation is that CloudFormation will recreate the AWS infrastructure that you need, and we've embedded in CloudFormation Microsoft PowerShell so that we're actually using the Microsoft recommended management infrastructure, PowerShell, to script out the Microsoft servers on top of the AWS infrastructure. So what this means is that you can feel good that the PowerShell is approved PowerShell from Microsoft or from your organization, and that PowerShell is building exactly what you expect, and you don't have to learn a different management tool to stand up the Microsoft servers. But PowerShell can leverage and take advantage of AWS CloudFormation. Now, once you've stood up the Microsoft servers on Amazon, you can monitor hundreds of counters in a service of ours called CloudWatch, monitor those counters, and you can tune and determine, well, are my instances properly sized for RAM, for CPU, for I/O, for network access? And you can tweak and tune the instances to make sure that your Microsoft environment is both high performance and low cost. So these are some more specific reasons for running the Microsoft servers on AWS. Now, I wouldn't tell you to just take it on complete faith that you can run these servers at scale and everything will run great. I prefer to give you an example, the example that's listed here for the Amazon's own implementation of the Microsoft servers. So about 3 or 4 years ago, we decided to migrate the Microsoft servers from on-premise to AWS. And at the time, we migrated 200,000 Amazon users to Exchange, Skype, and SharePoint using the Amazon corporate image. And we are running the configuration that you see in the slide here. We're running on 4 regions, US West and US East. We have the majority of Amazon employees in the US. We're also running in Europe in our Dublin region, and we're running in China on the bottom right. And then these 4 regions are connected together through IPsec VPN that's running over Direct Connect. So the deployment of the Microsoft servers and the CloudFormation templates that I talked about a second ago are how we've stood up a Microsoft servers deployment in AWS, and I have some data points here around 26 Exchange servers for this user population. We have 4 servers per availability zone. You can see in each of these regional boxes that we're running Exchange across multiple availability zones, 3 availability zones in the case of 3 regions and 2 availability zones in one of the regions. And so should we lose an availability zone, we can take advantage of capabilities in Exchange to continue operating without any downtime. We're using the database availability group architecture, the DAG architecture in Exchange for high availability. And this is what supports AWS or full Amazon users across Americas, EMEA, and Asia. And so we have a very large, and we have many other customers running the Microsoft servers on AWS. Now I wanted to sort of go from, okay, well, CloudFormation lets you set this up, and you can use CloudFormation and embed PowerShell inside of that, and then stand up these servers. But I thought I would actually show you a quick example of what I'm talking about when I mention using CloudFormation. So I've got, if you look on the screen here, I've got a little graphical depiction of a CloudFormation template. And I'll click on the view in the designer here. You'll see what was in my slide there. And this is a graphical depiction of the deployment that we'll be running on AWS. And you'll notice I have a code window on the bottom, and I have the servers listed here. And I can drag and drop connections and security groups and wait conditions. I can modify my general farm architecture graphically. Whatever changes I make graphically are reflected in CloudFormation code, which you're seeing here. For the purposes of today, I won't get into the exact details of CloudFormation on this template, but what I would like to do is let's actually run this CloudFormation template, and we'll come back to it and see the SharePoint server that I'm going to go ahead and stand up. So what you're looking at here is the CloudFormation service, and I'm going to run a stack for deploying a single SharePoint server. I'm asked for a couple of pieces of information. I'm going to call this SharePoint for today's webinar, and I can choose the size that I want to run SharePoint. You can see I can pick any of our instance types. I will, I need to go ahead and create a key pair. Let's create a key pair very quickly here. And it looks like I'm in US 1. So go ahead and say we are going to create a key pair called US West 1-KP, and that key pair has been downloaded. So if I now switch back to my template here, let's just select my key pair, which I just created, and I'm going, just for the sake of demonstration purposes, going to allow myself to access SharePoint from anywhere on the internet. When this webinar is over, I'll go ahead and delete this wide open security group, which is actually not a best practice. So we're going to create SharePoint in this stack. We will name this stack SharePoint, and let's go ahead and we can see what we're creating. This is where the CloudFormation template lives. One of the interesting aspects is that when I create a stack, I can click on cost, and I can directly see the cost of all the resources that I'll be deploying. And in a few minutes, I'll talk about the cost of deploying Microsoft servers, and you'll see some cost estimates that come from this link. Okay, and I think everything looks fine, so let's go ahead and just say create. And this stack now is in process. Close down my email. Okay, and if I select my webinar here, I'll be able to see what's going on here. So let's come back to this SharePoint stack and just continue in my PowerPoint, and we'll come back and take a look at what's happening. So the next thing I want to point out is, okay, so we've talked about the ability to use CloudFormation. CloudFormation uses PowerShell. We're able to deploy the Microsoft servers. We've created a quick start that allows you to run all of the Microsoft servers on the AWS cloud. And so this is what we sometimes call an accelerator, because it consists of multiple quick starts that are pulled together. It includes the quick starts for SharePoint Exchange, SQL Server, and Active Directory. And you can see the link on the screen here. If you run this, then what you're really doing is you're kicking off and running essentially a full environment of Microsoft servers. They run in the same common virtual private cloud, which I'll talk about in just a second. And so you can see the URL here if you want to go ahead and run all the Microsoft servers as a one-stop solution. You can also modify the pieces. CloudFormation is modular, so if you want to make changes to just SharePoint or just Exchange, you can make those changes, save this accelerator locally or to your own S3 buckets, and then your changes will be picked up by the larger CloudFormation master template. Okay, so this is what it looks like on the left side to actually go ahead and kick off that Microsoft servers on AWS accelerator. And let's go into a quick demo of what this looks like. So in order to show this demonstration, I'm going to go ahead and load two users. I'm using the Workspaces services, the Amazon Workspace service. And what this allows me to do is run Windows 7 or run Windows 10 with or without Microsoft Office included. And I'm basically simulating two users. But these desktops are hosted on AWS. I don't have any separate laptops in my room here for these clients. So let's just run through quickly the end user experience. So I'm logged in on the left side as Beth Jacobs, and let's go ahead and we'll just use each of the servers quickly. And we're going to send something to Len Henry. You'll notice Len Henry is logged on to my AWS environment. And let's just tell Len that let's meet to discuss the all hands meeting. Okay, I'll send Len an email, and at the same time, here let's go into email for Len, and you'll notice that the email pops up, and it's let's meet to discuss the all hands meeting. What you'd expect. I can see that Len Henry, who is the left side of the screen here, is logged on. So let's go ahead and maybe do a reply to Beth, but instead of just replying, let's go ahead and find her directly in Skype for Business. So I see that Bethany says she's available. Hi, Beth. Do you have a sec to chat? Okay, and Len, that pops up immediately for Beth. So we sent a message, we've responded, and what's interesting is I can say to Beth, have you seen the latest EV blog that we will be discussing at the All Hands? This is one that Mike wrote. And, you know, we'll just say, no, would love to see it. Okay, so at this point, Len is going to let's go ahead and find this SharePoint page. We've got a team site here. Let's go ahead and we'll send the team sites over to Beth. So here are all of the documents. Whoops, let's include the link. Okay, and if we now click on that link, we'll bring up the team site that Len was just referring to, and at the same time we can share other information. So I can say, for example, to Len, let's and here is the blog that I think you referenced. Okay, let's pull up the blog. So this looks interesting, looks like something worth discussing. We'll send that back. Okay, and the same thing applies. Beth is now able to bring up this SharePoint site, and so we've basically shown that we have access to all of the functionality, not in any great depth, but we've kind of walked through the basic functionality of collaborating over email, promoting an email to an instant message, finding a SharePoint site and sending around links, and these are the kind of typical things that people want to do. Okay, so this is available all through CloudFormation, and this is a published solution accelerator on our Quick Start site. So if we continue a little bit further in the demo, or continue a little bit further in the slides, okay, let's dive in a little bit deeper and talk about what it is exactly that we just saw. So of course it was Exchange and SharePoint, a link server on the back end, a Skype for client, a Skype for Business client on the front end. SharePoint and Link both use SQL Server to store their respective data, the content database for SharePoint and the configuration information for Link. We also have stood up Active Directory. We've deployed all this from a single master template that's called the VPC template, the Active Directory template, a SharePoint template, Exchange template, Skype template. The SharePoint template is quite interesting because before the SharePoint template can run, before any of the Microsoft Server templates can run, they need to stand up Active Directory, and they need to stand up, SharePoint needs to stand up SQL Server. And so we're running Active Directory, SQL Server, and then lastly we layer on SharePoint. The servers that are part of this accelerator come out to be 14 servers deployed across 2 availability zones in an HA configuration, and we're supporting 10,000 users out of the box. You can see the other data points here: 5 gig mailboxes, voice over IP, video, web conferencing, IM. You saw a couple of the SharePoint templates, and this whole thing costs about $14 per hour to operate. Okay, so that's sort of what the solution looks like. And from an Amazon perspective, let me go ahead and actually show you what this looks like inside the AWS console. So if I switch over here to EC2, or if I switch over here to CloudFormation, and we take a look at the stacks that are running. Okay, let's take a look at the Microsoft Server stack. Well, I'm in Northern California. That's what the problem is. Okay, and I've got quite a few stacks that are running, so let's take a look at just the stack that we care about. And this is what I referred to earlier, that we have a master template, which is calling Active Directory, Web Application Proxy, and the rest of the servers that you see here. And if I'm gonna dive in and let's narrow this down to what's running inside of the VPC. So if I click over here on the AD stack, then I can look at what are the outputs that are created by this SharePoint template. And one of the first outputs that gets created is the VPC ID that's listed here. So let's go ahead and grab that, and let's go to EC2. And within EC2, let's take a look at what's running inside of that VPC. So let's again make sure that we're on US West. And we'll filter by that. I can actually just say, well, we can just filter directly by that VPC ID. And now what you're seeing are the servers that were created by that CloudFormation template. There actually are more than 14 here because I've added some load balancing servers and I've added some additional SharePoint app servers. So this reinforces the point I made earlier that you can take our CloudFormation templates that we publish on Amazon.com and you can use them as a jumping off point for further customization. And what's interesting about this, I'll just pick one sort of quick example. If I pick my domain controller 1, you can look at lots of information. So you can look at, for example, the IP address that the domain controller happens to live on. I'll make that a bit bigger. I can also confirm or verify that this is running out of this particular VPC. I can look at the security groups, the firewalls that make up domain controller 1. And so I have all kinds of information about exactly what's running on all of the servers from an AWS perspective. Okay, and I can also RDP into these servers, and so if I decide that I want to connect to this server, I won't go into logging into each server and showing you what they look like, but I could log into each of these servers and bring up, for example, the SharePoint Central Admin console or the Link Control Panel console, and look at these servers from an application perspective. Okay, so let's jump back, and on my previous slide, I talked about what made up the solution from a Microsoft perspective. What you're seeing here is an architectural diagram of the servers from an AWS perspective. And so you saw that I filtered on a single VPC. We were running all of the Microsoft servers in one Amazon VPC, and that creates this integrated experience where things like sending an email allows me to see in the Outlook client that my client is logged into and available through Link. You'll also see that when I stood up these servers, you'll see that the top half of my diagram is availability zone 1, and the bottom half of my diagram is availability zone 2. And if you notice, almost everything looks identical because we're essentially running the same architecture mirrored in both availability zones, so that if we were to lose an availability zone in this architecture, our elastic load balancer would just route traffic to the remaining availability zone, and we have a high availability architecture. So users can come in from the internet, go through our internet gateway, hit a load balancer. What I'm not showing in this diagram is that if I wanted to, I could also set up this very last bullet. I could also set up connectivity to on-premises through Direct Connect over on the right side, and Direct Connect is our direct private networking link to a corporate data center, allowing you to have access either through your corporate network or through the internet. And of course, you can set up both. Okay, we have a DMZ here, so if I want to log in where I started to RDP into my environment, I would RDP in through a remote desktop gateway. From that gateway, I could issue PowerShell commands to manage my backend infrastructure. I could use EC2 Systems Manager to manage this environment, or I could use just RDP and hop into another backend server. And I'll talk a bit more about management in just a second. Okay, now a few more details about the Microsoft architecture that's running in terms of infrastructure. Exchange uses this database availability group architecture that I mentioned we had deployed for our Amazon deployment. What that means is that we are copying all the user mailboxes on servers that are in both availability zones, and we actually have multiple copies of mailbox servers. And so should I lose an entire server or should I lose just a mailbox database, I have the ability to recover either within an availability zone or through a different member of the DAG in a different availability zone. We're using link paired pools in this environment. And so you'll notice my link front-end server, and I have a replication of a different pool for my link front-end server in a different availability zone, providing essentially the same high availability architecture. For SQL Server, you'll notice that I have a SQL Server primary and a SQL Server replica or secondary, which I'm using for SQL Server always-on availability groups. What that means is that before I write any information, before SharePoint writes any information, for example, to store the contents of a blog on my primary, it's also written to the secondary before SharePoint says that the write was successful. And so we have two replicas that are always in sync using SQL Server always on. What's nice about the Microsoft servers is they support what Microsoft calls this brick architecture, which means I can essentially scale any of the roles that you see here. I can add additional SharePoint web front ends, and they'll just provide horizontal scalability. I can add additional Exchange mailbox servers for additional horizontal scalability, and list those additional Exchange multi-role or mailbox servers in my DAG for HA. So the brick architecture allows this very basic farm architecture to be scaled, scaled in linear increments to support, for example, 100,000 users. I should mention that in the Microsoft world, these servers have capacity calculators that allow the Microsoft administrator to define, in the case of Exchange, for example, how many users do I have? Typically, that's the same as how many mailboxes I have. To input what is the size of the mailboxes? How many messages are sent on a daily basis by an average user? What percentage of users send attachments? What is the average size of those attachments? And so by inputting that information into the Microsoft calculator, the Microsoft capacity calculator will tell me what are the minimum hardware requirements needed, including for virtualization, to have a supported architecture or a supportable architecture that passes Microsoft tests for not putting too much load on any individual resource. And so we would start with these calculators. That would give us an architecture that's supportable. And then, like you see on the screen here, we then map that to AWS infrastructure. And then, as I said a few slides ago, we can then tune and optimize the AWS infrastructure. So we may get a recommendation from Microsoft to use Xeon, a Xeon 8 processor instance, and through testing, I may discover that my assumptions were too high, and I can actually scale that back. So this is the basic process for mapping the Microsoft architecture to AWS resources. Now, what's really interesting is if I run the Microsoft servers quick start, I wanted you to see that you have full control of the infrastructure and the application. And so on my screen here, you'll notice that I can define, what do I want my network ranges to be? My network, the network that I want to use on AWS, maybe I want to have that be, maybe I want to have that similar to the CIDR range that I have on premises. Instead of, if I use 10.1.0.0/16 on premises, maybe I want to use 10.0.0.0/16 in AWS. And so I can identify my network configuration and subnet addressing, subnet 1, subnet 2 for the private subnets. I can identify public subnet addressing. I pick the key pair for my SharePoint example. I can choose the instance size for my remote desktop gateway instance, the instance sizes for my domain controllers. So without going through all of this, you can see, even though I'm running this AWS quick start, this accelerator that combines multiple quick starts, I have full control over what is the name of the domain I want, what is the DNS name of the domain I want, what is the version of SQL Server I'm running, what is the product key I want to use. So you have complete full control over the architecture at the Microsoft and AWS level. And these are these two screens you're seeing here are parameters for CloudFormation. So this is all one integrated DevOps automation tool. Now, if I run this Microsoft Servers accelerator quick start, I've clicked on that link that I showed you earlier, where I can click on the cost of the infrastructure that I would be standing up. And in this particular case, it comes out to about $9,997, approximately $10,000 per month for 10,000 users, which translates to 99.97 cents per user per month, or $13.70 per hour for this Microsoft Server architecture, supporting 10,000 users, 5 gig mailboxes, and 1 terabyte SSD storage for user profiles. Okay, so this is the detailed cost information about my remote desktop gateways and my domain controllers and my SQL Server. I've got my 2 SQL servers. They're running with Windows and SQL Server Standard on an R3 to XL. I'm using the on-demand pricing, and so you can see that we have that detailed costing of the entire solution accelerator. And by the way, this link here for details is the same link. This is actually pointing to the Amazon Simple Monthly Calculator, but this gives you the same information had you clicked on the CloudFormation link for the cost of the templates. This is another view of the Simple Monthly Calculator, showing that total cost that I mentioned earlier. And there you have it. That's essentially how we would automate running the Microsoft servers on AWS. And if you remember all the way back to my very first slide, or my second slide, I talked about how DevOps and optimization are some of the key benefits for running in a cloud environment. And you've gotten a flavor or a sense for the DevOps side of running these Microsoft servers. And you can also get a sense through the AWS console that I can tweak and tune and choose different instance sizes. I want to say a word or two about licensing. And so for the Microsoft servers, if you already own licenses for Exchange and Skype and SharePoint and System Center, you can bring your own license. You can use your existing licenses and import them into AWS. And so if you already have perpetual licenses, most customers have automatically own these licenses through their Microsoft Enterprise agreements. You can bring those into AWS and you don't need an additional license. For Windows Server and SQL Server, you can either import your licenses as BYOL or included models in which you're using Windows servers or SQL servers in which Amazon is providing the license for you under a program called SPLA, Server Program License Agreements. Okay, so you have both options, BYOL and license included. And I've listed on the right that you can also get all sorts of instances with different software pre-installed from the AWS Marketplace. You may, for example, want to run SharePoint pre-configured where an ISV vendor or a customer like yourself has set up a particular, say SharePoint wiki that you really want to take advantage of. So rather than loading just vanilla SharePoint and then adding in the wiki functionality, you can find a lot of these kinds of solutions in the AWS Marketplace. And the AWS Marketplace also uses CloudFormation to stand them up. And you'll be billed in the Marketplace on an hourly basis. Okay, so if we peel the onion back even a level deeper, I want to say a few words about architecture and SharePoint and SQL and continue the discussion of DevOps. So in terms of architecture, I'll start with networking and security. We're using this concept called the virtual private cloud that allows you to configure IP ranges, subnets that are defined as public or private, routing tables, which instances and which subnets are allowed to route to the internet or other subnets. You can define security groups, which are really firewalls, network access controls, which allow you to define networking in and out of a subnet separate from a firewall that supports an individual instance. We also support virtual private cloud flow logging, so you can look at the logs for all network traffic in and out of any one of the subnets. I talked a bit about remote administration with Remote Desktop Gateway, and in general, we recommend this concept of least privilege. In other words, you really should set up firewalls and network ACLs that provide the least privileges, the smallest set of privileges that you need to allow these servers to run. Okay, and if I dive a little deeper into SharePoint, just the SharePoint piece of this architecture, you can see a diagram similar to what I showed earlier, where there's a web tier, an app tier, a database tier, and an Active Directory tier, and each of these tiers can live in their own private subnets. So we have a subnet CIDR range 10.0.0.0/19 for all of these servers, and then we would carve up the subnets for each of the individual application roles, as well as carve up the subnet for the public DMZ roles that you see over here on the left with the NAT gateway and the remote desktop gateway. And like I showed earlier, elastic load balancing distributes traffic across web front ends for users who are coming in from the internet. And this is all part of our region architecture. And the top and the bottom, like I showed before, represent availability zones. If I lose an availability zone, my remaining availability zone will be able to handle traffic as directed to it through the elastic load balancer. I mentioned SQL Server, and I mentioned always-on availability groups. This is a bit of a deeper dive into what an always-on availability group looks like. And in this case, an always-on availability group uses this concept of a listener. A listener is really the abstraction for whether I'm pointing to the primary or pointing to the secondary. And the main point is that we have, in an Amazon region, we'll typically use synchronous replication between the primary and the secondary, so that should there be a hiccup in the primary, the secondary will always be up to date. And there's a witness role, which is detecting whether the primary is online. If it's offline, the listener will update this DNS name that you see here and point it to the secondary, and SharePoint will, or a .NET application will continue running without a hiccup. Okay, and I've talked quite a bit about CloudFormation here. I just want to sort of go back and mention that CloudFormation is our service for automating deployment of resources. CloudFormation starts with these templates that are formatted with JavaScript object notation, and when you deploy CloudFormation, it's referred to as a stack. And I showed you all the stacks that make up the Microsoft servers accelerator quick start. And I mentioned that PowerShell can be slipstreamed into the CloudFormation, so that we're combining both PowerShell at the application level and CloudFormation at the infrastructure level. Okay, and in the particular example of the Microsoft Server solution, I alluded to this earlier, but the master stack is really starting the AD stack first because everything in the Microsoft world relies on AD. And if I want to run something like SharePoint, well, the next thing I have to do is run SQL Server because SharePoint takes a hard dependency on SQL Server. In the case of Exchange, it has a dependency on Active Directory, and Exchange extends the schema, the Active Directory schema. We can't have Link and Exchange both extending the schema at the same time, and so Link waits for Exchange to extend the Link stack. Okay, so this is, again, I'm peeling back the onion a bit deeper, and these 6 layers are how we've actually organized the Microsoft Server's accelerator, and each of these stacks are individual quick starts in and of themselves, which we've just tied together for the accelerator. Okay, and if you want to really sort of look at what this looks like, we have a statement called depends on, and in this case, the AD stack has a statement called depends on, where we're saying that the AD stack is going to be layered on another stack or depend on another stack. So in this case, the Microsoft servers all have a dependency on AD, and this is sort of what these templates look like, where you'll call out a stack and it has a resource type of a stack name, and the stack we're pointing to the stack in an S3 bucket on the internet, and it would have a number of parameters. Okay, and to peel the onion back even a step deeper, you can store these CloudFormation templates on GitHub or any Git compatible service, and Amazon we provide our own Git compatible service called AWS Code Commit. And you can see here that I can look at the status of something for the Enterprise Accelerator. I can also add new. I can update a template and then add it to my repo. I can commit that repo, and then I can say let's go ahead and not just commit it, but let's update let's update master or update my DevOps my DevOps branch, and this is all integrated into the AWS DevOps story. Okay, and that's so that's the overview of running the Microsoft servers on AWS. I hope you can see that we have a great set of technologies and some good reasons for running on Amazon. Thank you very much for listening today for Microsoft servers on Amazon Web Services. Thank you.